Okay, we're going to talk some more about the absolute value, and I did this on the first video we talked about. So I'm just going to review and then elaborate a little bit more. So remember, if we have our absolute value function, it either be f of x or y, in this form, a absolute value of b times something in parentheses, x minus something, that should be absolute value plus d, then this is going to be the vertical dilation. We'll talk about that. And this would be the horizontal dilation. This would be the horizontal shift and the vertical shift. And let's kind of talk about these dilations a little more specifically. In other words, A, the number in front, this represents what the vertical dilation would be. And remember, if it's greater than 1, it stretches it. So if this is my basic function, y equals f of x, I'm sorry, the absolute value of f of, I'm sorry, y equals the absolute value of x, or f of x equals the absolute value of x. This is my basic function. All right. So if a is greater than 1, something like this, it stretches it vertically. So you can see how this would be stretched up vertically. We say stretches it. So it makes it skinnier, so it kind of pulls it in. By stretching it up, it goes in this way. And then if a is a fraction, the absolute value of a is between 0 and 1, like this, we say it compresses it. So it would kind of flatten it down. So it would bring it down. So that's a compression, bringing it down. This would be a stretch, bringing it up, so it would look like this. So if you took these corners and you moved them up, higher, higher, it would actually make it get skinnier. Okay? Now, the number in front of the parentheses inside the absolute value is the horizontal dilation. And it kind of does the same thing, we just kind of think of it horizontally. So if b is greater than 1, like this, then what it does is it compresses it horizontally. Well, if we take this and we compress it horizontally, that means we push it in like this. And we push it in, what's going to happen if I push this in? It's actually going to go up. I'm sorry, this is what I started out with. So this is my absolute value of x. If I push this in, if I push these sides in, they're going to kind of squeeze up, you know, like, I guess like this, you see. So if you push it in, they would squeeze up. Like that. So it's the same idea. It creates the same thing as a vertical stretch. So horizontal compression does almost the same thing to this particular function as a vertical stretch. And then if this is like a number between 0 and 1, inside, this is what we call a horizontal stretch. So rather than compressing it, it stretches it out so it would pull it out. So again, if we had something like this, here, I guess you can see this, and I pulled it out, it would go like that, like opening scissors. I should have had some scissors, that would have been fine. Okay? So that's kind of what's happening. So that's what we talk about, a horizontal stretch or a horizontal compression. All right? Or a vertical stretch, up like this. So it kind of pulls that up. Or vertical compression. And the numbers inside do that. So you want to know generally what to do, but the way I do these, I kind of fix that with the shape equation. So just by getting a couple points, we see right away what the actual combination of both these situations can end up being. So let's do some examples. And there's the first example we'll talk about in this video. And that's going to be the absolute value of, it's going to be 1/2 the absolute value of x. So I see I've got a 1/2 in front. So that means I'm going to have a compressed. It's going to be a little bit flatter. But we don't really have to, we'll get some specific points when we check our shape equation. So if we look at this, first of all, we have there is no horizontal shift. This is x minus 0. This is like x minus 0. So there'd be no horizontal shift, but there would be a vertical shift of -3. So my transformation would be 0, -3. And I can write it as an ordered pair. That's going to be where my new 0 will be. And then I'll try my values over here. This is my shape equation. My shape equation is just y equals 1/2 the absolute value of x. Now that's just the equation without the horizontal and vertical shift, and that's going to give you actual shape. So if I put a -1/2, if I put a -1 in here, the absolute value of -1 is 1, 1/2 of 1 is 1/2. 0 is 0, and again 1/2. And you could use the 1/2, or you could use 2. If you don't like to use fractions, you could use 2, negative 2. The absolute value of negative 2 is 2, 1/2 of 2 is 1. And you could use positive 2, and you'd also get 1. So you could use some extra points if you don't like fractions. And then we just graph it. So we graph, here's my graph paper I can use on this one. And then I'll just graph my new 0. We want to put a red dot there, and that's going to be 0, negative 3. And then my key points, I can go negative 1 up 1/2. Or 1 to the right, up 1/2. Remember, this is the horizontal move, is negative is to the left, positive to the right. Or I could go negative 2, 1, negative 2, and up 1 from the 0, 0. Now we're going from 0, 0. Or I could go positive 2, 1, 2, or right 2, and up 1. And there's enough points there, and then you get your straight edge. Always make your line straight. And I know my slope is going to be 1/2, so I can check some points over here. We'll get a nice clean graph, and you can see how that is compressed vertically. Some books use the word shrunk, but we'll be consistent. We'll say compressed. Our book uses compressed, and there you go. That's what it looks like. And you collect it, and I usually use a pencil because if I mess up, I can, if I don't get it right through the points, I can always rewrite it. Okay? And now this one over here is a little bit more of a general example, and this is a little more difficult. So let's take a look at this. Now, when we look at our general form, if you look at your general form over here, A, B, x has got to have a 1 in front of it. In other words, we can't have anything in front of the x. So in this case, we've got the 1/4 in front. So I have to get a 1 there. So I have to figure out how I'm going to do that. So this is kind of the technique I use. So I'm going to rewrite this. And I'm going to try to factor out a 1/4. So sometimes it's a little bit hard to figure out how many times 1/4 goes into negative 2. So what we can do is you can write this down as a number with a 4 in the bottom, which 2 is the same thing as 8 over 4. That might make it a little bit easier to see. Now I can get this 1/4 out, so I'll say y equals negative 3 times the absolute value, and I can put the 1/4 out in front of the parentheses, and now I've got a 1 in front of the x. And then if I take the 1/4 out, I'm just going to divide the bottom 4 out, so all that's going to be left is an 8, so it's going to be negative 8, parentheses, plus 4. And after a little bit of practice, you can get pretty fast at these. Now you always want to check it, because sometimes you can get fouled up. So what's 1/4 times x? 1/4 x. And what's 1/4 times negative 8? Well, 1/4 of 8, or 8 divided by 4, is 2, so it checks out. So now I got my data that I want. I can see that this is going to be my horizontal shift. Negative opposite sign is this vertical shift, and we say that's the same signs. So opposite sign, same sign. So my horizontal shift will be 8, and my vertical shift will be 4. And then this is my shape equation over here. So and I'm going to write it over here. So we just see, so the shape equation is y equals, and everything except for the shift, negative 3 times the absolute value of 1/4 x. And then we just use our table of values on this shape equation, and we'll get the shape, and we'll just graph it from that new 0. So here's your x, here's your y, and we just are going to minus 1, 0, 1. You can use those numbers. Now if I put negative 1 in here, 1/4 of negative 1 is negative 1/4. The absolute value of negative 1/4 is 1/4 times negative 3 is negative 3/4. I put 0 in, and then if I put 1 in, I'm going to get the same thing, negative 3/4. So those are my moves, or my shape, from this 0, 0. So when we graph it, And I had to expand my graph paper a little bit. So here's my graph over here. Now my new 0 is at 8,4, so I'm going to put that down. That's going to be what I use as a red dot. That's my transformation, 8 to the right, up 4. So I go 8 to the right, up 4, and there's my new 0. And then from here, I use my shape equation. And from here I go -1, so that's 1 to the left, down 3/4. So -1, 1 to the left, and down 3/4, so I have to kind of eye that. And then 0, 0 is my 0, and I go +1, so that's to the right 1, and again, -3/4 is down 3/4. And there you go. Now you can think about the slope of this being as -3/4. So another way of getting some points is I could go down 3/4, down 1, 2, 3/1, 2, 3, 4. Or down 3 the other way. And you could kind of figure out another point that way, because this actually ends up being the slope, -3/4. Or positive, because we flip them. And then you just get your straight edge, and here we go. We could draw this like this. And this is a little bit longer, so I'm going to use a ruler because it's a little bit bigger graph. So like I said, I better use pencil just in case I don't get these points lined up. So there you go. But you got your 3 key points. That's all you really need. You can put some other points if you'd like to, but I like to live dangerously. Oops. This was a little bit off there. Oh, there we go. That's a little bit off because I kind of extended my graph, so I didn't really have everything even. So this should be probably down here a little bit more to get the idea, but these slopes are kind of negative reciprocals of each other. Or they're not, I mean, they're just opposites. So +3/4, -3/4. That'll give you that idea. So there you go. So that's a pretty complicated one. So you should be okay on that. Let's see how we did that. Now you can always pause these, go back and check them. And then you can take a look at them, and then you can actually just use it as an example. Try it, pause it, try it, and then check the answer. Oops, hope that helps.